So again, wanted you to mark as many as possible. So this first one really only has one side, side, side. Second one, why is this marked with an X right there? Yeah, what's that called? Cool. And so are these two triangles congruent? By what? Okay. All right, number 3. It's marked as what? Neither of those. Yeah, angle, angle, side, or side, angle, angle. So it's for sure that one works. But we also know that that is reflexive congruence. And so what else can we mark? We can mark angle, side, angle, and side, angle, side. Okay? And I want you to take note of this one because this is often an option for you where maybe one person is able to prove it with side, angle, side, like side, angle, side, but a different person sees this and can prove it with angle, side, angle, and it's fine. It doesn't have to be done one specific way sometimes. Sometimes there are options. So keep your eye out for those options and make sure that you don't lock yourself into one version. All right, next one, which is what? Angle, side, angle. What kind of angles are those that you need to keep your eye out for? Okay, and I'm asking you these questions because obviously today we're starting proofs. Do we have enough information to say those lines are parallel? To positively confirm that they are and prove it? Yeah, we do. These two angles, here and here, so we could say converse of what?
Alternate interior.
Awesome, good job. Alternate interior angles theorem. If we needed to prove those lines are parallel, we could. Okay? All right, and then down here, this one is what? Side, side, side. You're not going to get a whole bunch of side, side, side proofs, but they come up. So just keep your eyes peeled for them. How'd that go? So yesterday we did some sort of pre-proofs and checked. So let's try an in-context problem real quick. We're going to talk briefly about CPCTC and then, well, hopefully it's brief. And then we're going to go, oh my word, give me a break. And then we're going to go into the proofs, which is basically the end of our stuff. So I think I'll just pause, let you read it, just because it's good practice to read your own problem. And get maybe 30 seconds or so. Barely. You just squeezed in here. All right, what do you think? While you're kind of waiting to say something, I'm going to just label the ladder as 10 feet. Do we have enough information to determine the height up the building or the house or the distance from the bottom? No, not from what we were told. I feel like I must be zoomed in or something. Yep, that's why. So how can he determine where to place the ladder to be sure it reaches the last window? What are we really talking about here? Yeah, and which theorem is that? For this one specifically, I mean. The ladder doesn't change length, right? So that's, yeah, there we go, HL. Because the ladder is H, and then one of the legs, if you keep it the same distance from the house, the other leg will be congruent because of HL triangle congruence. Look where he stuck the ladder. Is that a good idea? Okay. This problem is kind of stupid, just so you know. Sometimes math people, I think, are so mathy that they kind of lose touch with reality, and they write, like, who's going to do this? Just take your ladder and be like, honk up, move it down, right? Anyway, that's just, has anybody ever used the ladder before? Did you calculate where you're going to put it, or did you just stick it up there and adjust it, right? Now, there is a relationship, actually, for OSHA safety standards, which you should try to match or to meet, and that is that the base down here should be 1/2 of the length of the ladder to be safe. It creates what we call a 30, 60, 90 triangle. It's a special right triangle. We'll learn that in Unit 8. And it's around that ratio where the distance from the building is 1/2 of the ladder is safe. It's recommended to do it that way. So I do actually do that when I put my ladder up, because it's not like I want to fall off of it. Okay, so why don't you grab your notes and that reference sheet from yesterday, so it was pink, and let's talk about CPCTC. Try saying it fast, CPCTC. It's a tongue twister. Here, scoot your chair in. I told him I was going to stand right here. How's this for comfort zone?
Very claustrophobic over here now.
All right, CPCTC. Here's what we're learning. Have your pink paper out. How's this feel for you? Too close? All right, CP stands for corresponding parts. We talked about that yesterday. CT stands for congruent triangles, and that means once we know the triangles are the same exact triangle. And then the last C stands for the fact that they are congruent. So corresponding parts in congruent triangles are congruent. And that makes sense if you pause and read between all the wording of the theorem. Okay? Which is, let me go to yours. So corresponding parts, we talked, means the same position in the figure of congruent triangles. That means we have to prove this or be told. So on your paper, write this. Okay, don't make assumptions, either prove it or you're told that. And really, this is where we start the process. Even though the letters are in the middle of the CPCTC, we actually start there. We need to know the triangles are congruent, and then we can use that to make other pieces congruent. Okay, so this is easy to conceptualize and just in reality. I'm not actually going to stand here. But I will stand over here. Like, go to any clothing store. If you buy a shirt and there's like 50 other shirts there in different sizes, things that you can count on being the same are the design, the color, right? Like you don't expect differences in those kind of things. Not really, like maybe subtle ones. Or like you guys all have a Chromebook from the school. If I say, look at your F key on your Chromebook keyboard, nobody expects your F to look weird compared to anybody else, right? It's congruent. If I say all Chromebooks are the same, i.e. congruent, then everybody's F key or space bar should be the same. That's all we're saying, okay? When a car company spits out a bunch of cars, you get in one and you expect that seatbelt or that seats or the buttons on the screen, all of that you expect to be the same as this one over here for the same model and year, right? It's saying that things that are identical have identical parts. That's all it's saying. Do you want to write that? Because CPCTC sounds kind of wordy and official. So I'll write that just because things that are identical have identical parts. Now, can I compare the F key to the G key? Can I compare the space bar to the backspace key? So that's the idea behind corresponding parts. It means that they have to be the same piece of the figure of the triangle. So I can't compare a vertex angle to a base angle or some version of that. So we've already used this just a little bit, but we can use this to solve. We can also use it to prove, or in proofs rather. So let's look at this one. It's not on your paper, but just look up here. So, are these triangles congruent? That's where you start. So I'm going to ask that question. Are triangles congruent? Do we know for sure? I do.
You can use certain details to say that it is congruent.
Like what? Like do...
The angle on the far side and then the congruent lines.
So is it are they congruent?
Yeah.
Corbin.
Yeah.
By what? Okay, if you're saying I don't really know, study please. Yes, by angle, side. Okay? We have a congruent angle marked, we have 260s shown, and a congruent side. So the triangles are congruent. We have now proven that. So now we can say any corresponding parts are also congruent. Which means what? So any corresponding, I'm going to abbreviate that, parts are congruent. So like what is this question mark right here? Okay, and all we have to do is copy paste because we know it's congruent to the other 85 as long as we're looking at the correct angle, meaning it's corresponding, okay? So like this one is the same as that one, so it's 85 degrees. How do we solve for x? She's saying set them equal. Why do we set them equal? They're exactly the same. We're comparing the left driver's seat to the left driver's seat of two identical vehicles, right? So we are saying they are equal, and then we just solve from there. I'm not going to solve that. So that's one way we can use CPCTC. We were sort of told the triangles are congruent. We actually had to make sure by using AAS this time. Once we knew that, we could set any corresponding pieces equal to each other. Okay? So let's try this one. I'll give you just a second to work on that. Actually, maybe like 1 minute. I want you to go beyond just, did I solve it, to do I understand it?
unless you're plugging in shit.
Yeah.
Okay, here's where you should be. Are the triangles congruent? By what? Angle, side angle, right? So we have those two. And then notice that the two triangles are mirror images of each other. So this becomes, triangles aren't bad. Sometimes they're confusing, but that identifying corresponding parts can be confusing in certain figures. So be careful with that. But obviously now we know that these two angles are congruent. So we can just set them equal. Okay? By what? CPCTC allows us, once we know the triangles are for sure congruent, we know corresponding parts are as well. Identical figures have identical parts. Okay? So is this a triangle? Clearly not. But it tells us that the figures are congruent. I'm going to have you move. This isn't working. It didn't yesterday. So I'm going to give you this warning. Yeah, and then you're going to move somewhere else. It's just too distracting. See how this is 4 letters instead of 3, but it still tells us the figures are congruent. So what can we do to solve? It says find x and y. Why? Those are what?
It's told to be congruent when they're on the same angle.
So what do we use to describe that? He said they're on the same angle. What is that called? Corresponding angles, right? Corresponding parts. How do we solve for x?
135 equals 10x plus 60.
Because they are corresponding parts. Good. Okay. Like I said, triangles sometimes can be confusing. The closer they are to an equilateral triangle, the harder it is to tell which angles correspond. Ones like this, it's pretty easy, typically. But remember, you can always use the letters of the name. So M and N go together, N and U, etc. So if you're ever confused, if you're given the name, make sure that you just read it. I didn't have a chance to mention this yesterday, but you can use this for side lengths as well. Like MN goes with TU, the first 2 letters. Or we could do like the last 2 letters. MP goes with TS. Okay? This one, it's obvious from the picture, but if you didn't happen to have the picture, you could use the letters to know which ones correspond. Okay. So I'm going to put these 2 up for just a second. Do note the names are given. Actually, just do the first one. The name is given, so you can figure out your congruent or corresponding parts. Let's take maybe a minute or 2 on that. Go ahead and solve that one. Okay, let's talk about what you did on this one. So, let's solve for P first. We were told that these triangles are congruent, so that's not something we had to worry about. P is on WX, so it goes with ZY. Now, I think that was obvious in this picture, but just want to keep reminding you of how to read notation. So, how do we solve for P? Yeah, that one was kind of easy. So, P is 1. All right, let's do Q. How about Q?
2Q plus 3 equals 11.
Okay, so he's saying this piece equals this piece. Is that a safe thing to say? Technically, yes, but be careful because were we told that these triangles were congruent? Is that the triangles we were told were congruent? No. So do you see how these two lines I have highlighted are pieces of the triangle? Like just a part of a length, not actually the length of the side length of the triangle. So if we were not given these, could you set those equal? No, because it's parts of, and we wouldn't know for sure if they were equal parts of a length of a triangle, right? So the fact that those two 5s are there does allow us to set those equal, but only because those two 5s are equal to each other. If this was like 4 and 5, do not set those equal, because now they're not the same.
But then you wouldn't be able to solve it if they weren't there.
Right, correct. You would not be able to solve for Q. So probably a safer way, just conceptually for this, would be 2Q plus 3 plus 5 equals 11 plus 5. And we know because of the plus 5s being on each side that it's going to cancel. Like we'll be able to just subtract them and they'll cancel. But again, if one of them was a 4, then this equation would still be true, whereas without the 5s it wouldn't. So make sure you're comparing corresponding parts, not corresponding parts of parts, if that makes sense. Okay. All right, so CPCTC. Hopefully that's making sense. Here's a couple good ones. Are these good? Let's see. Yeah, do you see what I mean by, let me zoom in on those. It's harder to figure out which angles are corresponding. Do you agree? Like, does the 69 go with the 75? That kind of idea. Well, obviously not, but what does the 69 go with? Yeah, if we use the name, now it's easy. It goes with D, so I can copy 69 right there. And then what does 75 go with? Goes with C. But if we didn't have the name, that would be pretty tough with these triangles that look kind of close together. Okay? And then here, A and D, we know they go together because of the name. So just wanted to show you that. We'll come back to that one soon. We did polygons. So let's look at some proofs. Let me know. I was wondering about this before class. Do you want to see a couple to see how these go and then try some? Or do you want to just try some? What do you think? You kind of did yesterday, but they were partially filled out.
Are you talking about proofs?
Proofs, yeah. Do you want to see a few flow and then do your own, or what? Take a vote. See a few, raise your hand. Okay, that's a lot of you. Okay, we can do that pretty fast, and then I'll let you work. We have still about 25 minutes. Melissa helped us out with this one yesterday. All right. I think it'd be good just to take note of kind of what you're looking for and not worrying about writing it all out. So look at all the givens. Remember, more givens are nice. It's a pain to write, but it's nice to have the extra information. So we have that two AE and CB, two sides, and AB and CD are congruent. But note that that is not marked in the picture. So what's a good first step? Yeah, especially with these, because we are looking for the notation every time. So we have AE and CD, and AB and CB. Sorry, I said it wrong. AB and I marked it wrong. Do you see that? AE and CB, AB and CD. There we go. Yeah.
Are like A, B, and C, D parallel?
If they're not told to be and we can't prove it, then we can't assume. Yeah. All right, and then B is the midpoint of ED, which is really a way of telling us what? Yeah, this is in the proof. We would have to write it, but it's really telling us that this is true. And so what's the reason for these being congruent, the whole triangles? We know it's SSS. What is number 2, the reason for the pink tick marks? Awesome. Definition of midpoint. This brings up a good thing to remind you. We know midpoint means it splits it in half, so I can put these pink tick marks here. However, if you put those there and forget to define it, then you're missing a line. So don't forget to go back and state it in your proof. That doesn't happen on a guided proof, but on your own it can. All right, so you guys remember this symbol? The upside down T?
Yeah.
No. No. Perpendicular, yeah. What does it make? Yeah, so we have 90s in here, okay? So lots of perpendicular stuff. Where can I go put 90s? There. There, and we have AC and DC congruent, so put that there. What is this building to? Probably, or potentially. Okay. By the way, notice that it's like the less than symbol right here. That's sometimes a keyboard shortcut for an angle, just so you know. Instead of like going and finding the angle symbol. So angle BAC, that one, and that one are congruent. So what, just looking at the picture, what is this one? Okay. This is going to be angle side. Why are B and E congruent? It's on that sheet. Do you remember that one? Number 2 is definition of perpendicular. Definition of perpendicular lines. But why are B and E congruent? Yeah, all right angles are congruent. That's kind of a weird theorem, but that is that one. Okay, let's see if we can find one that's not partially done. Yeah, let's do this one. I'm going to give you a second to think through your proof. And I'll set it up while you're thinking. Anybody have a plan? Okay. True. Okay, so here's my suggestion. As soon as you see that you're proving two lines are parallel, or excuse me, two triangles are congruent right there, I would make this list that is going to help you think through your plan. Also, we always need to start by putting information into the picture. So S is the midpoint of QT. That tells us that these two side lengths are congruent. Have we said that in our proof? No. So this is what I mean. We need to mark it in the picture, but we can't forget to say it in the proof. Okay, it also tells us QR and TU are parallel. As soon as you read parallel lines, you're thinking angles, 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 right? That's all we studied. We didn't ever study lengths with parallel lines. We studied angles. So what angles are going to be helpful in here to prove congruence? T, that's not a good color. T and Q are congruent. Why? Those are alternate interior angles. R and U are congruent. Why? Also alternate interior. Okay. What else do we have in here?
Could you possibly say they're also vertical in a way? Since
These two are vertical.
Oh,
You may not say R, U, T, Q are vertical. They are not.
right.
Yeah. So do you see how now we have multiple ways to prove this? But definitely we're not using hypotenuse leg. Okay, we're not using side, side, side because we only know one side length. But we can use these others. So all that stuff is in the picture. Now we got to go put it in our proof. So what the pink line saying that those two segments are congruent, what's the reason for that? QS is congruent to TS. What was it? Definition of midpoint. Now, even though we know all three angles are congruent, is that enough to prove? Is angle, angle, angle one of them? Nope. Okay. So which route do you want to go? We could say angle Q is congruent to angle T. Why was that again? That's alternate interior angles theorem from our parallel lines. So now we have, we need one more thing. So which one do you want to put in here?
Wait, why can't you just do angle, side angle right now?
Right now? Because I only have side and angle. I don't have another angle in my proof yet.
Wait, what about S and then like TS and then T?
What? You got to define sides or angles. You can't just say letters.
Like the angle S.
Yeah, what about? There's 4 angles at S. Which one are you talking about?
What do you mean? The vertical.
I'm talking about 1, 2, 3, 4. So which angle are you talking about?
And then the T to S, that line. And then angle whatever at T.
Is it okay to call angle T angle T? Yeah? Because there's one angle there, right?
Like, so that, why can't you just do that?
Because we haven't said anything in our proof about the blue angles. Do you see that?
Oh,
That's what I was saying. Just because it's in the picture doesn't mean it's in the proof.
oh, so you just put it before you said it.
So we have to say angle, be specific, RSQ is congruent to what? UST. Make sure the order is correct. So R corresponds to U, right? All right, now we have angle. We have 2 angles and a side. Just because I wrote them over here in this order doesn't mean that's the order we're going to use them, right? I'm just pointing out that we have 2 angles and a side in there. So which theorem, if we're going to go with what we've called out in our proof, which theorem is it? This is angle, side angle. Okay? So again, if you go put SAA in your proof, or for your reason, it's wrong, because that's not what we called out. We called out angle, side, angle, right? It goes in that order, angle, side, angle. It doesn't matter what order we put them in the proof. It matters what order they are in the figure. What?
The last one would be vertical, and then you have to do the next one.
Oh, yeah, I jumped ahead. This is VAT. And then triangle. Yeah, there we go. So that's a pretty typical triangle congruence proof, maybe 4 to 5 steps. Let me find one that is this one. So this is a CPCTC proof. And you're welcome to write this down, or you can just look on Google. I'll post these, but these ones are in this unit. These ones are the ones you have to be careful with because they involve going just a little bit further. Notice, we're not asked to prove two triangles are congruent, are we? Okay. We're asked to prove two side lengths are congruent, but we have no reason to assume they are at all. So the only way to get there is by going through triangle congruence and using CPCTC. So I'm just going to do this one. I'll talk you through it, but think with me, like kind of go with your plan. If I said you do have to prove that these triangles are congruent, well, we know that we should probably start with our list then.
Should we always put the list in other groups? Like if we just need it for...
I would, if you're like, I think as a student, if this is a struggle at all, write it. I mean, it helps guide your thinking. And it took me like 5 seconds, so it's worth the time. All right, angle D is congruent to angle F. Is that in the figure? Like, do I need to mark that? No, that's there. Okay, GE. Bisects angle DEF. Is the result of that in the proof? No, it's not. Okay, so what does that tell us? The fact that GE bisects angle DEF tells us what? This is an angle bisector. What does it tell us? Both sides are congruent? Yeah, it's telling us this is true. That angle and that angle, right? It's bisecting angle DEF. So I've put it in my picture. It's not in my proof yet. So I need to say angle DEG is congruent to angle FEG. Again, make sure you do the correct order and in terms of which pieces correspond. Why is that? Why was I able to write that line in my proof? Awesome. Angle bisector theorem. That one doesn't really have an abbreviation because, I don't know. I suppose we could, but. Okay, so I have two angles marked. Now what? That's not enough to prove congruence. And why are we proving congruence again? Like nothing said show the triangles are congruent, so who cares? Why are we doing that?
We have to prove that segment length DG and the side length DG and FG are congruent.
Yeah, and if we know the triangles are identical, aren't all their pieces identical? That's the idea. If we know the triangles are identical, we can say anything is identical then, as long as it's corresponding. Okay, here's what I'm thinking. I'm not going to get side, side, side. I don't even have a side marked in here. It's definitely not hypotenuse leg. I see two angles, so I'm probably going to look here, right? Because the other one, side, angle, side, one of the sides I'm trying to prove. How can I use that in my proof? Does that make sense? So which of these two can we go after? That's kind of the reason I have you write the list, is it helps, hopefully it helps direct you. Anybody see? Yeah. Okay. It's not going to be ASA, but good thought. Because we need, for ASA, we need a side, and that would be this side and this side. Do we know anything about those? Okay. We're trying to prove these two sides, so we definitely don't know those. Do we know anything about this one? Okay, tell me about that one. It's nothing to do with the bisector. What does that mark mean?
Reflective property.
Yeah, so this is not an angle. So GE is congruent to EG because of the reflexive property. Okay, now we have enough information to say the triangles are congruent. Again, even though the proof didn't ask us to, so angle or triangle DEG is congruent to triangle FEG. Why? Angle, side. Okay? All right. We have one more step. Once we get to this point, usually we have one more step. And that is, now we know we have identical triangles. We have just proven it. So all corresponding parts are congruent. Okay? Once we know the triangles are congruent or identical, then every corresponding part is as well. And so we can just drop this last statement in here. DG is congruent to FG. And what's the reason? CPCTC. Okay? So most of the time, a CPCTC proof is just a triangle congruence proof with that last line added on. Okay? Occasionally, you'll have to do a CPCTC in the middle so that you can continue proving something else. But I don't give you those too often. What do you think? Yeah.
Could you maybe skip the angle side part and then just write CPCTC after reflexive property?
What does this line do?
It proves that everything about the angles
Yeah, and so without that, then we don't know that the parts are.
are. Okay.
Yeah, so we have to have that. Any other questions?